All right. Okay, and we are live. Thank you for joining this webinar. My name is Eitan Suez with Tetrate, and what I customarily do on webinars is kind of give a 5-minute grace period for attendees to join. Since we just started the event, I see a few people are here. Feel free to say hello in the chat. This event is, or this webinar, the title is Introduction to Envoy Gateway and Tetrate Enterprise Gateway. So please do say hello. Hi, David. Thank you for joining. So if this looks like the right subject, you're in the right place, and we will start momentarily in just a minute or two as I sort of give a short grace period to any attendee or any person who wishes to attend who may be a straggler. Hi, Niraj. Thanks for joining. Okay. All right. Well, I'm excited to share with you what I have in store. I hope it'll sort of hit the spot, as they say. We'll get. I'll explain myself momentarily. Okay. All right, so this event is being recorded. My name, again, is Eitan Suez, and the title of this webinar is Introduction to Envoy Gateway and Tetrate Enterprise Gateway, which is a little bit of a mouthful. My name, again, if you're curious how to spell it or what have you, is Eitan Suez. My role at Tetrate is doing training and education, among other things, and I really enjoy spending time with the community, talking about technology. The main objective of this webinar is for us to learn about Envoy Gateway project by example through explorations. And so what I'm going to do is I'm going to try to minimize my time in these slides and spend the majority of the time just hands-on on the keyboard exploring the product. That's the way it ought to be. But having said that, there's always a little bit of context that needs to be set to kind of explain the general sort of subject. And so we'll start with a series of slides, not very many, but before long, we'll sort of move on from an introduction, or maybe I should say an orientation, to getting hands-on. I trust that everyone can hear me well, and that there are no technical issues. If there are, please do holler. And let's explore Envoy Gateway together. So let's begin with an orientation. Let's talk about ingress. That's the main sort of term that I want to sort of throw out there to sort of get us on the same page. And what I want you to sort of imagine or visualize is an environment, and that's principally today a Kubernetes environment in which we deploy applications. By we, I mean it could be multiple different teams, right, that maintain microservices. In this illustration, I'm showing a variety of services, sort of communicating with one another in some fashion or another. It's not really to be exact in any way, but the point is that there may be multiple applications, maybe shared services, what have you, and the main so the crux of the subject that we want to talk about is how exactly do I expose my applications or my APIs to the outside, right? Through some kind of gateway, and typically the way this is done is the main sort of point of entry into our system is a layer 3 or 4 load balancer, behind which is a gateway that's programmable, that's layer 7 capable, that can be programmed to then route traffic to the appropriate locations based on the way that we specify things in terms of URLs and paths and what have you. So that's the general picture that I want to sort of impress upon everyone, the sort of the problem that we wish to sort of address and discuss. And if I had to maybe sort of translate this into, say, a user story, right? It would go something along these lines, right? That maybe as an operator, I might want to provision and configure gateways so that I can control access to APIs and applications. And what's interesting is that there may be multiple personas that are involved in this, right? It's not just the operator who wants to provision a gateway and configure it and have control over access, what can come into this environment, but it could also be development teams, right? So maybe as a developer, I want to self-service the configuration of routing to my services and APIs so that my services are available to my end users, right? So we typically call this, I use the term ingress, we call it north-south traffic in sort of networking parlance, and as opposed to east-west traffic, which is usually sort of internal communication between services within an environment. All right, so that's sort of the problem in question. Let us begin to talk about it in more detail. Now, there are many different ways in which we can approach the subject. We can think of sort of the evolution of how we configure ingress, and it's kind of an interesting history. And so that's a chronological perspective makes a lot of sense, right? What I mean by that is we could talk about sort of the venerable ingress apps, like something like Apache or Nginx or HA proxy, and then maybe the creation of the ingress resource, the venerable ingress resource in Kubernetes, and talk about the evolution of how we configure ingress to our workloads in Kubernetes, and how over time maybe that's evolved, how Istio, for example, proposed maybe a different model for configuring ingress, and today we have the Kubernetes Gateway API, which we'll talk about momentarily. We can also look at the things from a different perspective, from that of a spectrum. Imagine a line where on one end is the most basic of needs, that is, we want to configure ingress traffic securely to our applications, but there may be many other use cases, many more features that, for example, API gateway products sort of exhibit, things like rate limiting capabilities and all kinds of security configurations, and there are many other sort of scenarios that we can discuss. So we can take it from that perspective. The perspective I'm going to take, of course, is the one that makes the most sense from the point of view of discussing the Envoy Gateway project. We're going to focus on Envoy. We're going to specifically focus on the fact that Envoy, the proxy, has many capabilities which we would love to unlock, right? Sometimes it's used only as a, strictly as a mechanism for configuring ingress, but it has other capabilities besides, and that's what I'm going to be focusing on. So as a quick sort of quick sort of recap of what exactly is the Envoy proxy, right? It's often described as a powerful modern proxy with many capabilities. And the term modern maybe deserves a little bit of a explanation or elaboration in that it's a relatively newer product compared to, say, Nginx. It came several years later and sort of came out of the box with capabilities that traditionally weren't present in other proxies. Things like the ability to remote configure the proxy, the ability for the proxy to have an API to hot restart and to sort of ingest updated configuration without really needing to be restarted in any way, and the support for more protocols, and both it being both layer 4 and layer 7 proxy and so on. Today, it's used in many large enterprises in production and at scale. It's written in C++. It's an open source project. It's a graduated CNCF member project. So that's in a nutshell a little bit about Envoy. And it's also worth stating that Envoy is really the workhorse behind the scenes in Istio. So when we talk about Istio, that term Istio is sort of front and center, but the main building block of Istio is Envoy. You could say that Istio is really nothing more than a control plane for Envoy. We use that term, right? The brains behind the operation, but it's all about managing envoys. And we know, for those of you who've looked at Istio, know that the Envoy is used in two main capacities. One as a sidecar in a mesh to act as both a forward and reverse proxy between services internally, but also as an ingress or egress gateway component in Istio, which historically in Istio, you would actually deploy those components at installation time. So Envoy really features prominently in Istio. And so the question that I want to sort of begin with is, what if we wanted to run Envoy by itself? And by that, there's really two meanings hidden in that question. One is we're not really interested so much in the service mesh use case and focus more on north-south traffic or ingress. And that's one. The other one is why do I have to have, if I want to deploy Envoy, do I really need Istio? Or why can't I just deploy it by itself? So let's just run through this sort of mental exercise of, it's an open source project. It has builds, it has images. We assume we want to run it on Kubernetes. And so we could write a deployment manifest to deploy Envoy to our Kubernetes cluster. So what's the problem with that, right? You can think of the next step being the job of configuring Envoy. And Envoy configurations are notoriously lengthy. They're very, very long, and they're very difficult to configure by hand. In fact, Envoy was never designed to be configured by hand. Now, I cannot, because of the length of many Envoy configurations, I cannot really do a good job at really relating how long these configurations files are, but typically they're thousands of lines long. This sort of scroll that I'm showing on the right-hand side is maybe a tiny fraction of the full Envoy configuration. And you can imagine the challenge of managing that configuration by hand. And the truth is that Envoy wasn't really designed to be configured by hand. So when we look at the landscape, and this is an interesting link I want to follow for a second. Let's look at this link. This is a page from the Envoy proxy project, okay? The community page, which shows a variety of open source projects building on Envoy proxy. And there's a long list there. Maybe I'll come back over here. And so all of these logos that I'm showing here are all projects that employ Envoy. And so that begs the question, Envoy seems hardly ever used by itself. There's always some other component, whether it's Istio or the Ambassador project. I think it's been renamed Emissary or Contour. They all employ Envoy. So why are there two, right? And the answer is really Envoy was designed to be driven by API. It was designed for there to be a control plane that sort of configured Envoy, sort of a level of indirection there. And just to inject a little bit of humor there, it reminded me of this famous quote by Yoda, which you all know, always two there are, right? A control plane and a data plane in this context. And what I mean by that is the data plane is Envoy, or multiple Envoy proxies, which we want to control and configure. But there's this other component, the control plane. And so let's explore that, because that's essentially what Envoy Gateway is. So if you go to the Envoy Gateway project on gateway.envoyproxy.org, I believe it is. Let's check real quick. Gateway.envoyproxy.io, right? This is the front page for Envoy Gateway, and you can go and drill down to the documentation, and there is that diagram, that illustration that I was sort of showing just a moment ago. And so what we see here is Envoy Gateway acting as a control plane to manage the configuration of, not just the configuration, actually, the provisioning, the lifecycle of these Envoy proxies. So a little bit about the Envoy Gateway project, right? It was announced as a collaboration between multiple parties, multiple vendors that all had products based on Envoy proxy, VMware, Tetrate, Ambassador Labs, and others. There was a blog entry by Matt Klein, the author of Envoy proxy, and it sort of made sense when you think about it, the idea that why not build on a common foundation? Right, we all need a control plane for Envoy. Why not do it in the open source? The announcement really was at the inception of the project, and a couple of years have gone by, and a lot has happened. Right, today, recently, Envoy Gateway has reached version 1.0. It implements the Kubernetes Gateway API specification, which is very timely because it also recently, I think today it's at the specification is at version 1.1, so it's no longer sort of an experimental thing. It's something that's really come alive. And the confluence of these things is really almost like a perfect storm, if that's the right expression. So think of this as a common foundation that vendors can build on to add more features. But really, in my mind, the objective of Envoy Gateway are making the provisioning of Envoy easy. Okay, that's historically been sort of a little bit of there's some friction there. Making configuring Envoy practicable, right? Having some easy way of configuring Envoy without directly editing the Envoy configurations. And then finally, I think a really important objective to unlock the many capabilities of Envoy proxy, which there are many. So we must begin, I think, by talking a little bit about the gateway, Kubernetes Gateway API, right? If you go and visit the Kubernetes Gateway API sort of SIG page, you are presented with this diagram, which I think says a lot just by itself. And in my mind, this Kubernetes Gateway API is almost the culmination of lessons learned, over years of trying to design ingress in one way or another, and then coming up with just the right formula of something that's flexible, something that's extensible. And so the lessons that we've learned over the years that are embodied in this model are as follows. The recognition that there are multiple distinct personas, right? You've got the infrastructure providers, which implement the controllers that are those control planes we were talking about a moment ago. Then we've got the operators who really are concerned with provisioning gateways and configuring them. But then you also have the development teams who are really configured with the routing of requests to their application, not so much other facets of how that gateway is configured. And the fact that there are multiple development teams that need to work together, that we need to support different types of models, maybe a shared gateway models. How do we have multiple teams configure their facet of routing for a particular host name, but it's really a shared gateway behind the scenes? How the fact that operators really need to be in control in terms of who is allowed to even configure some aspect of their gateways, right? And then the recognition, as this picture shows, that there are maybe multiple protocols and they're configured differently. So why not design routes, provide a different resource per protocol, so to speak, right? There's maybe an HTTP route and a UDP route and a TCP route and so on and so forth. And then finally, the recognition that there's no API, a single API to rule them all. There are always going to be more features, more capabilities that maybe are not reflected in this API. And so it's important to also address extensibility. And in my mind, when I think of the Kubernetes Gateway API, I think of an offering of a model that addresses all of these concerns. And over time, as I've looked and played with this API, I've come to really concur that this is really an important step that can and act as a standard, almost a glue between a variety of projects that complement each other. All right, I hope that makes sense so far. Let's carry on. We're almost there. So let's talk specifically about the Envoy Gateway API, because it's an implementation of the Kubernetes Gateway API. But it goes further because Envoy Gateway is really designed to unlock other capabilities, not just ingress and routes, but more things. And so it adds more resources to the mix. It adds an Envoy proxy resource, and a patch policy resource, and a few other resources there: client traffic policy, backend traffic policy, security policy. There may be others. This is not necessarily an exhaustive list. But the basic idea here is to allow you to configure more aspects of ingress. How you want your default sort of out-of-the-box configuration of Envoy to look like. You may have multiple different sort of profiles. And so there's the concept of a gateway class. You can have multiple gateway classes, each represented in a slightly different configuration of Envoy. If you want to configure Envoy directly, you can patch it directly with Envoy patch policy, very similar to how you do Envoy filters with Istio. But the three other ones, in my mind, are more relevant. Right, if you want to configure in a more fine way the aspect of the communication between your gateway and clients, there's a client traffic policy. If you want to further refine how the communication between your gateway and the backend workload, there's a backend traffic policy. Or if you want to apply some kind of facet of security, authentication, authorization, there's a security policy that associates to those Kubernetes Gateway API resources. All right, so if you were to ask the question, what does it mean for Envoy Gateway to reach version 1.0? In my mind, it's two things. One is that it's a compliant implementation of the Kubernetes Gateway API. But it's also the fact that it now supports a very long list of scenarios that map to capabilities built into the Envoy proxy. If you want to configure your gateway with retries, timeouts, redirects, URL rewriting, if you want to configure rate limiting, if you want to configure routing in all kinds of different ways with conditions and do traffic splitting and canary deployments, or if you want to configure TLS termination or pass-through, or mutual TLS, or go further and talk about authorization, authentication, JOT tokens, OpenID Connect support, and so on. All of those are now actually supported in Envoy Gateway 1.0. And I get the sense that the team is just getting warmed up. Their velocity is great. On the documentation website, you can go to the tasks section, and there's a quick start. There's a variety of scenarios, all sort of enumerated under each category, whether it's traffic management, security, and so on. So that's where the project stands today, and that's what I want us to explore together in just a moment. And so what I've done is I've sort of cherry-picked a few scenarios which sort of build up on each other, from the simplest way of sort of looking at Envoy Gateway to doing something a little more realistic. So we'll start with installing Envoy Gateway. I've built a portal. There's a URL, and you can visit it. It's freely available, and it contains a variety of sort of explorations that you can run on your own, which is terrific. We're going to start by installing Envoy Gateway, provisioning a gateway, configuring routing, showing how shared gateways function. We'll do TLS, we'll do redirects, retries, rate limiting, authentication. And in the course of going through these, we'll learn a great deal about Envoy Gateway, what it feels like, right? How you exactly do things, how you configure it. And so why don't we simply get started? And so let me show you more or less what I've got going here. And please holler if you think that the font size is maybe a little too small. On the right-hand side, I have that website, and I can flash the URL one more time if you want to grab it. It's deployed on GitHub, e.g. webinar. Font size is fine. Okay, perfect. Thank you, David. And on the left, I have a terminal, just an iTerm 2. I'm running on a Mac, and this is a local machine. I'm going to use a local cluster. I'm going to deploy a local Kubernetes cluster. More about that in just a minute. You have actually two options. So as you go through this, there's a whole sort of menu, list of activities you can run through here. And we're going to begin by downloading some artifacts, a bunch of YAML files for configuring gateways. So you can just simply click on this link, and you can do this on your own time later on. Don't worry about doing this now. We're going to do it together right now. And I'll grab these artifacts and move them to this empty directory and unzip it or untar it. And if you're curious what's in that folder, they're basically a bunch of YAML files for each of the scenarios that we're going to go through, right? So I've got my artifacts, and the next thing I need is a Kubernetes cluster. So you can do this on any Kubernetes cluster you want. There's really it's a double-edged sword. I really wanted to do something on GCP, but provisioning a cluster takes a few minutes. I don't want to, and then also when you create routes that tie to host names, you got to set up DNS. You can create external DNS, but it still takes something like in the order of 60 to 90 seconds, sometimes longer, for time to live and things like that for host names to resolve to their IP addresses. So I'm going to use a local Kubernetes cluster. I'm using K3D, which is just like Minikube or Kind, another popular option for doing Kubernetes on your local machine. And so all I'm doing here is creating a K3D cluster. I called it my Kate's cluster. And what I like about it is that on a Mac, the sort of the ingress gateway IP address, like localhost on my host machine, is going to resolve to the ingress gateway that I provision. So it's very easy for me to then sort of demonstrate ingress scenarios with it. So great, we've got a Kubernetes cluster running. The next sort of decision point I have here is what do I install? And I really haven't talked about Tetrate's product yet. So this is probably the time to do it. I have the option of installing Envoy Gateway. It installs with Helm. Or I can install the Tetrate Enterprise Gateway for Envoy, which also installs with Helm. So they both have Helm charts. And so it behooves us to just take a moment and talk about, well, what's the difference? Why would I even want to look at Tetrate Envoy Gateway? I'm doing it here for a very selfish reason, in that Tetrate Envoy Gateway, you can think of it as an opinionated distribution of Envoy Gateway. It's by no means a fork. It's actually the Envoy Gateway project, untouched. As a matter of fact, many of Tetrate's engineers are contributors to the Envoy Gateway open source project. But it's opinionated in that it's oftentimes described as a batteries included version of Envoy Gateway. It's pre-configured with, for example, support for rate limiting, so that you don't have to reconfigure Envoy Gateway to support rate limiting scenarios or what have you. It also has unique features. They try to add value in a number of different ways. For example, adding the ability to support web application firewalls. We provide recipes for Istio integration, kind of an enterprise offering where we add CVE checks and otherwise manage the life cycle of Envoy Gateway, dealing with upgrades without downtime, things of that nature. So that's what it's about in a nutshell. If you go and visit the Tetrate Envoy Gateway page, and I'll share with you this link. Maybe I'll put it in the chat so that you know what I'm doing. You'll come across this diagram, which I think in my mind does a great job of helping us understand what is the difference between Envoy Gateway and Envoy. And here in this diagram, what you see the Envoy Gateway components. There's Envoy Gateway, which is the control plane for one or more Envoy proxies, which you see there on the upper left-hand side. But there's also other components. So Tetrate Envoy Gateway pre-provisions an instance of Redis and an instance of the Envoy rate limit service so that you have support for rate limiting out of the box. For example, there's also this Tetrate Envoy Gateway Manager, which acts as, again, a management plane perhaps for Envoy Gateway, which helps with the sort of scenarios such as upgrading and the Envoy Gateway component itself, or doing CVE checks or things of that nature. All right, so let us come back to my little cheat sheet here. And what I'm going to do is simply deploy Tetrate Envoy Gateway by doing a Helm install. Okay. So I'm doing a Helm install, and I'm installing the Tetrate Envoy Gateway. So either Envoy Gateway or Tetrate Envoy Gateway actually deploy the same thing, the Envoy Gateway component, which we'll see in just a minute. They deploy everything to a namespace called Envoy Gateway System. And here you see the pods that are coming up in that namespace. So there they are, just like the diagram we were looking at a moment ago. There's the Envoy Gateway itself. There's the rate limiting component. There's the Redis backend. And then the TEG, the lifecycle manager for Envoy Gateway. What is actually absent here, which is interesting, is the gateway proper. There is no Envoy provisioned here, and that's because the Kubernetes Gateway API has a different sort of model for provisioning gateways than, for example, what you used to do with Istio, that you had to deploy it separately at installation time. Here, the creation of a gateway resource acts both as a means of configuring a gateway, but for provisioning it as well. And that's important to realize. So you can very easily, at sort of runtime, decide, oh, I need a new gateway, and you just kubectl apply-f a gateway resource, and you get yourself a new gateway provision. And we'll do that in just a minute. So I'm going to skip this external DNS portion that doesn't apply to a local sort of deployment of Kubernetes. But what I'm going to do is we always begin with the creation of a gateway class. Now, TEG actually already gives me that, so that's really superfluous. But a gateway class is nothing more than a sort of association of a name, in this case, EG, with the actual controller of Envoy Gateway, the gateway class controller there. And maybe I'll show you what that looks like here. Let me go ahead and apply that. So here we see the gateway class. Now, this is not the only way in which you could define gateway classes. There's an additional field in the spec for configuring Envoy through an Envoy proxy resource so that you could have technically multiple gateway classes. And the idea is that you can deploy multiple types of gateways. That's the basic idea. So we've got a gateway class, and really the interesting part is the gateway resource. So this is our first look at what a gateway resource looks like from the point of view of the Kubernetes Gateway API. So this is really, there's nothing specific to Envoy Gateway here. The main part is that, again, we're naming the gateway EG, but we're associating to the gateway class that we just created. And this is designed to be the simplest possible example that I could come up with. We're going to build on this momentarily. So here, all we're doing is defining one listener on port 80 for essentially the HTTP protocol. So we're essentially poking a hole in, and we're going to allow ingress on port 80. Notice that there's no host name specified here yet. So we can apply this gateway. And you may ask yourself, well, what's going on at this point? This is a resource applied to a Kubernetes cluster that triggers specific events in the controller, the provisioning of the gateway. And so we should be able to find it, right? And the configuration of the gateway. So if we look at our pods in Envoy Gateway System again, Envoy Gateway System, we should see a new pod on the scene. And you see it there at the bottom, Envoy Default EG. That's the sort of just-in-time provisioned Envoy Gateway. And we can look at our gateway resource. We could say, let's look at the gateway resource named EG in YAML. So this basically is just an echoing of the spec I just gave it, but it's got some extra parts which are really interesting in my mind. The first one is this on line 16 there, allowed routes, namespaces from same. This is a mechanism built into the Kubernetes Gateway API to basically say, I'm the operator, and I control who is allowed to attach routes to this gateway that I just provisioned, right? And here, the rule is, as long as the routes are defined in the same namespace where I provision the gateway resource, then I'll go ahead and allow them, for example. But we can use some kind of selector scheme whereby we label namespaces that are allowed to connect to a gateway in a different namespace, or something of that sort. The other part is the status. So if we look on line 22 there, we see all kinds of very informative pieces of information, the address at which the gateway is going to listen on. Now, because I'm running this on a local machine, that IP address is not going to resolve for me. As you know, Docker is not native to Mac OS, so it runs on the VM, so there are complications there. But in every other aspect, that's how that would work. And then you have a list of events, conditions, the fact that the resource was accepted, scheduled by Envoy Gateway for provisioning. And then there's even status information about the listeners. So you can see that there are 0 attached routes, and that the translated configuration has been sent to the data plane. That is a perfect example of how Envoy Gateway drives Envoy. So it configures Envoy, it generated an Envoy configuration for a listener on port 80 for HTTP traffic. Okay. All right, so how do we test this, right? Well, we should be able to verify that we have something listening on port 80. Right? If I call that gateway IP address, which in my case is going to be localhost, I get a 404. Now, we typically associate a 404 with kind of an error condition, but in this case, it's a testament to the fact that we have a listener listening at that IP address on port 80, and it returned 404. And why is that? And that's because we haven't yet defined any routes. Now, that embodies right there one of the major design decisions that was essentially borrowed from Istio, which is the separation of the definition of the gateway proper from the definition of a route. They're both equally important, and they each deserve their own resource, which is in contrast to the venerable ingress resource in Kubernetes, where you have one resource where you define both the routes and the configuration of the gateway. So here you have more of a separation of concerns, as it were. All right, let's carry on. So obviously the logical thing to do next is, why don't we deploy some kind of backend workload? And I'll just use HTTP bin because it's a very popular sort of example, sort of little app that will serve our purposes very well. So now I have a pod, HTTP bin, that's coming up. Now, we're not in Istio world, no Istio lands, so there's no Envoy sidecar here, right? This is just the HTTP bin workload running in my Kubernetes cluster. And let's take a look at the definition of a route. Okay, so let's look at this HTTP bin route. No, that's not it. Bat simple route. Okay, so here we have a definition of an HTTP route. We give it a name. And notice we're saying if the request is associated with a host name specified there on line 8, then route the traffic to the back end called HTTP bin listening on port 8000. So I deployed HTTP bin. If we look at the services, there it is. It's listening on port 8000. But no, there's some interesting sort of abstractions there. One is that a parent ref there on lines 9 and 10. Parent ref is an association to the gateway named EG. And so you see these polymorphic associations, and they're always described with the term ref. There's a parent ref or a backend ref in this case. And so we're saying we're defining a route for the gateway named EG. All right, so when we apply that route, and if we do the following, if we look at the gateway again in YAML, and look at the status section, under listeners there, line 40, we see attached routes is now 1. We have a new attached route. And so that's a good sign. That means that we should be able to then make a call through our ingress gateway to get a response from HTTP bin. So let's give it a try. Now this begs a little bit of an elaboration. What is this command? We're making a call to this particular host name, httpbin.esuez.org. I picked some random endpoint on HTTP bin, something that's going to return a JSON payload. But because I don't have DNS configured, I'm using a wonderful feature of curl, which says, okay, I'm going to provide how I want hostname resolution to happen. When a call to that particular host name is made, resolve it to the gateway IP address. So there's the call, and we see a response, and that's terrific. That means that our gateway is now configured. It was provisioned, the protocol was defined, and the route was added. So let us go then to the next logical thing to do. I mean, imagine for a second that we have multiple teams, right, and working in the same Kubernetes cluster. Now, I don't model that perfectly here because I don't bother to take the time to create a separate namespace or what have you. But let's say that they're responsible for a completely different set of applications, the customer service and the web front end that sort of makes a call to the customer service and returns HTML. So if I deploy that to the default namespace, there they are, they're coming up. I want to be able to expose this web front end for the customer service through that same ingress gateway. And so I want to be able to write my own route, right? So let's go ahead and look at that. It's another HTTP route. There's nothing new here. The only difference is the host name on line 8. We're actually saying if the request comes from this host name, then send it to the web front end service, the backend, not the HTTP bin backend, but it's attached to the same gateway. So now we'll have 2 routes on a single gateway. So let's go ahead and apply that. And then again, we'll put it through its paces. We'll test it. And there's a couple of things we want to test. First of all, does the route to this new customer service actually function? I'm making a call to the customer's front end, and I get back some HTML, and it looks like a list of customers. So that looks good. But what about the other call that we made earlier? Does that continue to work? And certainly it does. So we can support the shared gateway model with multiple development teams that essentially self-service their own routes, but they bind to the same gateway, which was provisioned by an operator. So this was the vision of that Kubernetes Gateway API, and now it's realized with Envoy Gateway. Now, a few other things we could try to do, which is terrific in my opinion, helps us learn a little bit more about Envoy Gateway. Let's look at this command. Let me try to sort of explain what it means, first of all. Because we essentially configured an Envoy, but we did it indirectly by applying a resource to a Kubernetes cluster that was picked up by Envoy Gateway, which translated the configuration to an Envoy config that it then pushed over gRPC to our Envoy. So here what we're saying is, the first thing we notice is that Envoy Gateway comes with its own CLI, its own command line interface called EG-cuddle. And one of the features of that command line interface is the ability to interrogate and to say, hey, show me the configuration of the Envoy proxy that you provisioned for me. And because Envoy proxies configurations are notoriously long, I just want to look at the routing rules. I don't want to look at everything. Show me just the routing rules. For the Envoy proxy, associated with a gateway named EG that I deployed to the default namespace. Now that gateway, the pod, is actually living in the Envoy gateway system namespace. And so we want to look at the actual raw translated configuration that the Envoy is actually given. So if we look at it here, and this is a little bit hard to parse, but if we look on line 10 and 11 and 22 and 23, what we see there is two routes are actually defined on that gateway. One for the domain http://bin.esuez.org, the other one for the domain customersfrontend.esuez.org. And then the routing rule there with a match prefix / that means all requests to that host name should go to a particular cluster, which is Envoy's term for a backend workload, which is defined elsewhere, right? And it has the name HTTP route default HTTP rule 0. So you can see a little bit of the internals of how Envoy Gateway works by looking at this. But it's very comforting to know that we can inspect the Envoy Gateway configuration very easily, so to speak. And it serves our purposes in two ways. If we want to learn more about Envoy, how to configure Envoy, we can use Envoy Gateway as a sort of a stepping stone or an aid, a helper to help us understand how to configure Envoy. But furthermore, configuring things with using the Kubernetes Gateway API is a lot more manageable than having to do it by hand like this. All right, so let us move on to the next logical thing to do. We've exposed two applications, customers and HTTP bin, over port 80. Now that's not realistic. We want to use TLS, right? We want to expose services over HTTPS. And so we have to make some decisions. How do we generate our certificates? And since we're in Kubernetes world, why not use a cert manager, which is a very sort of Kubernetes native way of managing certificates, right? And so let's go ahead and do that. We're going to add the repository for the Helm charts for Cert Manager, and we're going to deploy Cert Manager. And then the thing to note about this particular, command, this is a Helm install command that installs Cert Manager. But on the third line there, we see that we are turning on a feature gate, experimental gateway API support. And here, that's where sort of my mind is starting to click. When you have a standard that everybody agrees on, then all kinds of tools that you can bring to bear that sort of follow that standard. So here we see Cert Manager has some kind of integration with Gateway API as well. And we're going to explore that in a moment. All right, let me pause for a second because I see a question. kubectl get dash, I don't know if that's a -L or -I, requires comma separating selectors to combine them. But EG_ctl accepts multiple labels. Okay, so that's a -L to make them additive. It may be that it supports both, I don't know. And if it's the case that you have to supply it twice, that may be a little bit of an inconvenience. If it's an issue, bring it up on the Envoy Gateway Slack and get the feedback from the committers. Maybe that's just something that they'll just add in as a convenience at some point in an upcoming version. All right, so I've got Cert Manager running. Let's check. We have a Cert Manager namespace, that's good. And we can look at the pods and Cert Manager, and there it is, it's running. So how am I gonna do things? I'm gonna go a little, make things easy for myself and use perhaps something that's less than realistic, which is define a cluster issuer, which is a self-signed issuer. And what that means is an issuer of certificates, which issues certificates that are signed by a self-signed root cert, which is obviously not trusted. So we'll have to sort of work around that. But it's expedient and it's easy and it gets to the point. So I've got an issuer. And so now, if I have an issuer, that means I can mint certificates. And the way this works is I love it. It's remarkable. It reminds me a little bit of TDD. Okay, so if we let's first look at this resource. This is a redefinition of our gateway, which up until now had only a single listener on port 80. And what we're doing here is adding a second listener on port 443 for the HTTPS protocol, specifically for the host name http://bin.esuez.org. So we're concerned only with the HTTP bin workload and the route to that workload and not about the other customer's app. And here what we're saying is we want to terminate TLS, which means that we have to serve, the listener that is, has to serve the TLS certificate to clients. And it basically states here, Envoy, if you need the certificates, just look up this secret named HTTP bin cert. Now, where does this secret come from? It's almost like you're stating things as a fait accompli, an accomplished deed, so to speak. And this is brought to you thanks to Cert Manager. So if you backtrack to line 7 there, you could see an annotation that's really an instruction for Cert Manager to say, pay attention to Kubernetes Gateway API resources. And when you see a gateway created that contains this annotation, use the reference cluster issuer to generate the certificate in question and to generate the secret containing the certificate on our behalf. So that makes it almost transparent. It's like TDD without having to implement the code, or maybe the code's already implemented. So we can apply that. We can apply the gateway with the second listener. So we can look at this point. If we look at the gateway, we should see 2 listeners. I'm not sure if we're going to. So you can see, let's look at the status. So listeners attach routes 2. So the number of hyphens under listener should be 2. You see 2 routes attached to the first one, and there is the second listener, and 2 routes attached to it as well. So that's interesting. Because we have 2 routes, and they're both attached to the gateway, but the gateway has 2 listeners, we end up with an explosion of, we end up with 4. 2 times 2 is 4 routes. 2 bound to HTTP port 80, 2 bound to HTTP port 443. All right, so we've applied this. Let's test it. How do we test it? Let's access HTTP bin over TLS. So how do we do that? It's just a curl. Now I have to pass the -K or -- insecure flag because it's a self-signed cert. And I make a call to HTTP bin. Notice over HTTPS this time. And the call actually succeeds. We get an HTTP 200. I think this was just a head HTTP request, HTTPS request. And if we look at the secrets in default namespace, you will find out that the secret was created by Cert Manager. So now we have HTTPS. How easy was that? Right? That's wonderful. So next step is obviously we don't want to allow traffic to HTTP bin over HTTP. We want to redirect to HTTPS, right? So what I mean by that is this is the picture that we had a moment ago. We want something like this. We want a request to HTTP bin to return over HTTP to return a 301, which is a redirect over to the HTTPS scheme, which then would route the request to our backing workload. So how do we do that? Let's take a look at the config. So let me go ahead and copy that, and let's do a bat. So here, notice we now define 2 routes, 2 rules essentially. But what's interesting is line 11 and line 28. There's a new field there called section name. And that section name basically says this routing rule doesn't apply to the whole gateway. It only applies to the gateway listener named HTTP or HTTPS. So when requests come in over HTTP, we're going to use a filter, a request redirect filter to redirect the request to the HTTPS scheme. I'm basically reading lines 13 through 17 there. And then the client is going to see the status code 301 and repeat the request over HTTPS. And when that request comes in over HTTPS, it's the other listener. And so the other route, the one at the bottom there, will apply. And that route basically says, oh, okay, if you're making a call over to the section, to the HTTPS listener, send it to the HTTP bin workload in the backend. So let's apply that. And let's test it. Let's make a curl request to HTTP bin over HTTP, not HTTPS. And notice we get back a 301 redirect. Right. Now we could follow redirects. We could do something like, a curl -K -L. -L means follow redirects. And then we also have to say resolve HTTP bin esuez.org over port 443 to the gateway IP. And here you actually see the request being made, being redirected and sent back. And here we get the response. All right, so that works as well. And that's terrific. So now we're kind of happy. So let's treat ourselves and explore something that's maybe unique to Envoy Gateway. And what I mean by that is let's try a feature of how to configure traffic to a backend which is not supported by the Gateway API. And so one example of that is retries. Envoy supports configuring retries. So let's begin by looking at the gateway-related resources defined in our Kubernetes cluster. Make that a little bit smaller so it doesn't wrap around. Okay, so here you see the list of API resources defined on our Kubernetes cluster. These are primarily a side effect of deploying Tetrate Envoy Gateway, a Tetrate Enterprise Gateway for Envoy, I should say. And you see two classes of resources. You see the Kubernetes Gateway API resources, but at the top there, in the top section, you see all of the custom Envoy Gateway resources, the backend traffic policy, the security policy, and there are others besides. So that's essentially a hint that the Envoy Gateway API is a superset of the Kubernetes Gateway API, and it contains features that are not yet specified, or maybe will not be, I'm not sure, in the Kubernetes Gateway API. And so that leads us to this idea, which is part of the API spec. Let me, okay. And what you're seeing here is a page from the Kubernetes Gateway API that talks about this feature called policy attachments. And it's this idea that you can define resources that attach or associate with Kubernetes Gateway API resources. And that's primarily the strategy that Envoy Gateway project takes. So let's look at an example. That's the best way to learn. We're going to define a backend traffic policy. So let's do a bat. So this is a Envoy Gateway specific resource, but notice on line 7 through 11, we have an association to the HTTP bin route. So we're defining a backend traffic policy that applies only to requests that are routed for HTTP bin, not the other app, for example. And we're defining retries. We're saying we want to retry up to 5 times, and we're sort of showing off many of the features of Envoy here that you can have per retry timeouts with exponential backoff, and you can configure exactly on what conditions you should be retrying when you have a connection failure or when you have retriable status code, and maybe the HTTP 500 as well. And you can apply that. Let's apply that to our cluster. And the question then comes to, how do we test this? So let me explain how, and this is all taken from the documentation, right? I haven't really done anything myself. Let's look at this command. This is a watch command, which is wonderful for sort of monitoring things over time. It essentially repeats whatever command I give it every 2 seconds. And we're using, again, the Envoy Gateway CLI to look at the stats of our Envoy proxy, okay? And the specific stat, in this case, we're looking for upstream request retries. That's the name of one of the many metrics exposed by Envoy. And more specifically, this is retries that are associated with the route in question, the route to HTTP bin. So if we watch that, okay, and this metric is a counter. So you see that number 0 there at the top. That's the number of retries that have been done on that route so far. So now we can basically try to make a call to this special HTTP bin endpoint, which is going to return a 500. And guess what's going to happen? I mean, Envoy should be retrying that up to 5 times. So if I press enter here, and I get a 500 back because it gave up after 5 retries. But notice that counter went up to 5. If I do that again, it'll go up to 10, right? So retries are now implemented and they're working. Now, there are other ways in which you can look at these metrics. You know, one of the nice sort of features of the EG CLI is it makes it easy to bring up the Envoy admin interface for any sort of Envoy proxy that you have up and running. So if I look at the, this is the, if you guys have played with Envoy, you know what that looks like, right? This is the Envoy admin interface. It's not very pretty, but it's got lots of endpoints. And we could look at the stats, and we could look at the retry stats. And sure enough here, I'll make this a little bit bigger, you can see that some of these upstream requests, 500s and retries, are all set with a count of 10. There were 10 that had an exponential backoff. But notice that other retries to maybe another route, like the web front end, have a count of 0 because there haven't been any, right? Okay, so that's the Envoy admin interface. Not much to say, not much more for me to say about that, at least at this juncture. Another really cool thing is the fact that the Envoy Gateway logs are by default configured as JSON. So if I look at the last line in that Envoy Gateway logs and pass it through JQ, you can actually see the last request has a response flag called URX, which means upstream, what is it? Upstream retry limit exceeded? Yes, that's what it is. So another thing for those of you who are not intimately familiar with Envoy is you should know that Envoy has these response flags, and they all have these short names, which take maybe a little bit of getting used to. But here's that URX, upstream retry limit exceeded. So if you know how to read those short names and those response flags, you get a lot of insight into what actually happened with that particular request. Was it rate limited? Was there some kind of an upstream connection failure? Was maybe no route found to the back end, maybe because it was down, or in this case, the retry limit was exceeded because we got 500 errors up to 6 times. All right, so that's kind of cool. And then finally, the last thing we could do here is look at the updated proxy configuration. So we again look at the raw configuration of Envoy, and somewhere in here, we should see that retry clause was sort of translated, right? And I'm just going to search for retry. Here it should be over here somewhere. There we go. So we see retry policy on line 48. We're saying retry up to 5 times, and there's the back off, and so on and so forth. Retry on this particular types of errors. All right, so that's great. So everything Envoy Gateway is doing its job. I guess we don't have to check. We should maybe trust it, right? It's got a whole suite of automated tests after all. So let's go to another use case. Now, if you deploy Envoy Gateway without using Tetrate's product, here you'll discover that you have to reconfigure Envoy Gateway to also support rate limiting, and you have to deploy a Redis instance, and you have to communicate through configuration through an Envoy proxy resource the actual address of the Redis backend that's going to contain the keys, right? The entries that are upon which the global rate limiting is going to make its decisions. But with TEG, with Tetrate Enterprise Gateway, you don't have to do that because it's sort of out of the box. And here's just another example of a backend traffic policy. And I guess the thing to remark about this example is how simple this is, right? If you've tried to do this with Istio, you know it's not simple. And that's because with Istio, what do you have to do? Well, that feature is not exposed in Istio. So you've got to write an Envoy filter. You've got to patch your Envoy proxies directly yourself. And that gets ugly very, very quickly. Not to mention also deploying Redis and the rate limit service on your own. Here, it just comes out of the box, batteries included. You're saying, okay, here's the backend traffic policy for that same old route, HTTP bin. It's a global rate limiting. So if I have multiple envoys, they all have shared state, which is what you want. And here I'm saying I just want to limit the number of requests to 3 per minute. So if I just apply that, how do we test it? Well, we can send maybe more than 3 requests in 1 minute and see if we end up getting rate limited. So if I maybe step down to a bash shell, here you see 4 requests. The first 3 give me a 200, and the fourth one gives me a 429. And pay attention also to the fact that Envoy also adds all kinds of informative headers to the response. The fact that the request was rate limited, true. That the rate limit is 3 over a period of 60 seconds, that you have 0 remaining, and that in 17 seconds, this bucket will get sort of reset because it's 3 per minute. So if more than a minute's gone by, maybe it'll succeed again, right? And certainly it has. If I do it one more time, we'll see now we get 429s because it hasn't been a minute yet. So that works, and that's great. But notice how easy it was. Now, a couple of other things we could do. We can look at the gateway logs. So we look at the last request, and here you'll see the response flag says RL, request was rate limited. So again, you have information in the log that tells you exactly what happened with that request, why it returned to 429. Well, that 429 means rate limited anyway. So maybe it's not why. Maybe it's just that it did. Okay, so when you're doing rate limiting, the much more common scenario is rate limiting distinct users. And so obviously that's supported as well. Let's look at what that looks like if we do a bat rate limit distinct users. Here, the only difference is lines 16 through 19. I'm adding a client selectors section that basically means there's a condition of sorts. It's a selector that basically says, I want to look at distinct values for this particular header. So if the user translates to a header by the name XUserID with the user names or user ID, then different users are going to get their own buckets, so to speak, for rate limiting. Eitan is going to get 3 per minute, but John Smith is going to get his own bucket, and he's not going to be affected by how many requests I make, right? That's the basic idea. So if we apply that, we can then submit a request. Let's go back to Bash. So here, notice I'm passing a header, user ID Eitan, and I get rate limited after 3 requests. But if I change the user ID to hold on. If I change my user ID from Eitan, where is Eitan? Yeah, to say John, I'm not rate limited until I make my 4th requests. So each one of us get our own bucket, so to speak. So that's how that works. So rate limiting becomes a very common scenario that is very easy to configure, very easy to enable, to turn on. And that's what I mean by unlocking the capabilities of Envoy proxy through the Envoy Gateway project. And I feel like these extra resources are a natural extension of the sort of core API that the Kubernetes Gateway API gives us. All right, I think here all I'm doing is I'm looking at the Envoy config and I'm looking at the rate limit configuration, and you can see somewhere down here we have that header name X user ID on line 55. That's part of the configuration of the rate limiting on that Envoy. Right, and if we looked inside that Redis, we would probably find an entry in that Redis with the buckets in question or what have you. All right, the final scenario that I want to sort of go through is kind of an example in the small. Like I'm not doing sort of the most desirable option, which is turn on OpenID Connect, because that involves a lot of setup and or what have you. So I'm going to do some kind of security policy using basic auth as an example. Right. Now, the way basic auth works is obviously you've got to have usually, at least historically, some kind of HT password file. Right? With Apache, you define your credentials in the HT password file, and then when the request is made to, it's actually, you need to supply a username and password. So here, this is embodied through a security policy. So let's look at that. This is an Envoy Gateway resource. Notice, again, it associates to the route for HTTP bin, which means we can selectively turn this on for specific routes. We don't have to, if we don't want, say, basic auth on the customer's application, we don't have to. We do it only for HTTP bin. And the way that we configure it is we give it a reference to a name of a secret containing the HT password file. So we have to create an HT password file. So let me go ahead and do that. I'll create a single entry in it with a user named Eitan and a password called secret. And then I will create a Kubernetes secret from that file. So if we look at this command, we're saying create a secret by the name of HTTP bin users from the file in question. I can probably get rid of that HT password file because I've got my secret. And if I apply this basic auth YAML, I should be able to test that a request that is not authenticated gets back a 401 unauthorized, right? And if I instead pass for example, a username and password, we can sort of go through all 3 scenarios. This is the wrong password, but if I pass in the right password, which I think was secret, now I get a 200. So again, it's that easy to configure basic auth. OIDC obviously involves a little more moving parts, but it's also out of the box in the Envoy Gateway project proper. It's nothing proprietary. It's actually out there open source and pretty straightforward to configure. We can inspect the proxy configuration. I think I'll leave that as an exercise, but you have the details there if you want to really see how the proxy ends up being configured with the basic auth filter attached to in the filter chain to the listener of the gateway. There are a number of other really interesting, maybe I should just show you. Let's go to the Envoy Gateway docs. When you look at these tasks, the list of scenarios for which you have recipe, whether they're security related or whether they're traffic management related, doing traffic splitting or requiring HTTP3 or TLS pass-through mutual TLS. There's so many examples there. I really urge you to sort of go and take a look at these recipes, try them out. The bottom line is, I think Envoy Gateway, in my mind, really is true to its objective of unlocking many of the capabilities that have been in Envoy for a very long time, just not being used because it was sort of difficult to access, so to speak. Now, I've got another sort of scenario here, which is walking you through. This is just a sanitized version of something that's already documented here, which is how do you configure observability. You can very easily deploy Prometheus and Grafana and import some Envoy-specific dashboards. And before you know it, you send a traffic to your application, and you could see. Here, let me. I think there's some screenshots here, and I think I have a link to it as well. Yeah, there we go. Okay, you can monitor your Envoy gateways in style, so to speak. So here are some screenshots that show you what those dashboards look like. So these are out-of-the-box Grafana dashboards that the team has created for you to monitor your Envoy gateways. And there's 3 of them in all. I don't know if there are more, but you can import them into Grafana, and before you know it, you're monitoring your Envoy gateways. Those gateways are automatically annotated with the Prometheus annotations, so that the metrics are scraped automatically. That's something Envoy sort of gives you out of the box. So that's another compelling reason or at least compelling feature that complements sort of the ability to operationalize Envoy. And that leads me to maybe a few conclusions I'd like to make. So let's talk about takeaways. In my opinion, Envoy gateways come a long way, right? I remember that announcement that was made at KubeCon in 2022. Now we're in 2024, and the project is real. It's version 1.0. It's got all of these, supports all of these features that are baked into Envoy, and it's a fully conformant implementation of Kubernetes Gateway API. It unlocks the capabilities of Envoy Proxy. There's a lot of goodness to unpack, and this was really only an introduction. So notice how easy it was for me to sort of get going on it with this. And hopefully that's a sign of more goodness to come, so to speak. So I really invite you to go and try some other scenarios and give the Envoy Gateway project a try. So going back and just concluding here, if you want to continue the conversation, Tetrate maintains a community Slack organization. So if you want to join our community Slack and ask questions, there's the invite link, tetrate.io/Tetrate community. And that basically allows you to then very easily access a lot of my colleagues and myself at Tetrate if you've got questions. But really, honestly, if you've got questions about Envoy Gateway proper, you really ought to go to the Envoy Gateway Slack, which is also out there on the Envoy Gateway website. So it's easy to get to as well. All right, so that's all I have. I'd be happy to take any questions you have. But I really want to thank you for sort of spending a little bit more than an hour with me going through this. And I hope you found this valuable and useful, and hopefully will serve you well in the future. And then we hope to hear from you. And I'm sure we'll have more webinars as time goes by, and that you'll be able to join us for those. I see Jimmy is typing, so let's see what Jimmy maybe has a question. Just had a chance to join. Yes, a recording will be posted. That's a good question. Just watch for, probably you'll get a follow-up email since you've registered about the link to the recording. That will be posted. Also, I see David is asking, combining auth with rate limiting replaces the X-user ID header, so the client cannot override it. The header that you choose is really up to you. I don't see any issue with these features conflicting. Now, check the documentation, of course. There are, so the thing that comes to my mind, for example, is there are certain limitations. Like if you define a backend traffic policy for a workload associated with a specific route, I don't think Envoy Gateway currently supports multiple backend traffic policies. You have to define them all in a single resource. I think that's true, but I don't think that's really in any way a limitation, but I'm sure they'll address it at some point. So that hopefully answers that question, at least to some extent, not specifically. Assuming a paid license, does TEG have FIPS compliant images ready for 1.0? So I'm glad you asked. This is actually being actively worked on. I suspect that within a month, you will have FIPS images available for TEG. So yes, that will be included, but it's not a 1.0. It'll probably be 1.1 or something of that sort. But it's around the corner. So yeah, that's a great question. So that's the idea. At least the dichotomy between Envoy Gateway and TEG is, if you want, sort of value-added features, things like fixed compliance, which oftentimes is a requirement. That's what TEG was sort of designed to sort of provide the organizations consuming these products. Okay, I think we've reached steady state. Again, if you have more questions, join our community Slack and or reach us through the means shown here on this slide or what have you, and we'll be happy to continue the conversation then. Again, thanks for joining, and we'll see you in a future webinar. All right, bye everybody.